Hey everyone, in this video we'll be exploring aircraft, more specifically fighter planes. I was wondering, what is the correlation between fighter maximum weight and maximum speed? First, we'll explore the data as usual. I'll first start by getting the list of all aircraft data. We can get what this data looks like by taking a span of the first three elements, let's say. We see that it's made of a bunch of entities corresponding to aircraft. Taking the length of our data also gives us that we have almost 4,000 aircraft. What properties do aircraft have? Calling the properties of our aircraft data gives us many properties that we can use in our analysis, most notably maximum speed and maximum weight. Before we hop into our analysis, let's explore the data a bit. How is maximum weight distributed? To answer this, I'll get the maximum weight of all aircraft. Tallying the heads in our data gives us quite a lot of missing data, so we will clean our data using delete missing. After that, we can use a histogram to visualize the distribution of weights. But what is this data in terms of? Taking a sneak peek into our data using the shallow function gives us that the data is in pounds. We're using /n here, which is a postfix form of applying a function, to get a numerical output instead of a fractional one. We can convert this data to kilograms using unit convert, and we see that most aircraft are below 10 tons. So I was curious, what's the heaviest aircraft? Taking the maximum in our clean data gives us that the heaviest aircraft weighs about 1,000,000 pounds. That's certainly heavy. So what aircraft does this correspond to? We can use the take largest function of new data that is an entity association to find out. I'm going to add the /n, a postfix form of applying a function, to ensure I get a numerical answer instead of a fraction. We get that the aircraft is the Antonov AN225. Getting its properties gives us the same properties that we discovered before. I was curious about that aircraft's maximum speed, which turns out to be a pretty fast 527 miles an hour. On to another question. What are the top manufacturers of these aircraft? I can first get all the manufacturers using the aircraft data function. After cleaning it using delete missing, we can use counts to tally up the manufacturers, eventually putting them into a dataset for easy reading. I can see many familiar names here. Now, what types of aircraft are the most popular, and how equal is the distribution of built aircraft across aircraft types? First, let's get the data. Using entity value, I can set up an entity association with the number of aircraft built. Then we can clean the data using delete missing and arrange it in descending order using reverse sort before finally converting it to a dataset. We see that there's quite a steep decline already within the top 20. Let's now visualize it using a pie chart. We will deconstruct this code from the inside out. First, we'll take the values in our data above. Then, we'll use take list to take the top 100 aircraft, the next 200, and then all the rest of aircraft using up to. After that, we will map the total function onto our constructed list to get the total aircraft built. As you can see through the pie chart, it seems that the top 100 aircraft already make up more than half of all built aircraft. Now let's get into our speed versus weight question. First, let's look at the type of aircraft. Getting the type property of all my aircraft, cleaning the data, tallying it, and taking the largest 10 by the last element gives us that fighters are actually the most common. Let's focus on them now. How is their maximum speed distributed? I will first get the entity class of aircraft in which the type is fighter. On that, I will apply the entity value function to extract the maximum speed property. Then we can apply delete missing and get numerical data using /n, which is the postfix form of applying a function. We will now plot the data using a histogram. One can explore what the corresponding distribution is by using find distribution, but let's move on. Now let's answer our question. The way we'll do that is through making a set of coordinates with the maximum weight as the x value and the maximum speed as the y value using similar code to what we did last time. Markedly using entity class to get only fighter planes and entity value to get the actual values. I will select only data which is free of any missing heads using select and free Q. We can get a feel for the data by getting a span of say the first three elements. We see that the weight is in pounds and the speed is in miles per hour. Proceeding to plot it using a list plot gives us a decent positive correlation. Are there any anomalies in the data? For fun, let's find out. We'll use the find anomalies function on our weight speed data to find out. Find anomalies gives a list of examples that are considered anomalous with respect to the other examples. In other words, it returns out of distribution examples. It looks like there are a few. We can visualize these using the show function by setting up two different plots, with the anomalies having a plot style of large red points. Removing these anomalies will give us a very straight correlation between speed and weight, as one can easily see using the plot. Perhaps you can extend this analysis to all aircraft or other types of aircraft.